Hey folks, this is Robert Quinn here, your LinkedIn semiconductor industry content provider. Today I would like to introduce Adam Kahn to our new LinkedIn live series called Movers and Shakers, where we interview industry leaders in the semiconductor industry. Now let me give you a little history on Adam. Adam is the founder of AKHAN Semiconductor, which is a premier semiconductor company focused on diamond and nanotechnologies. Adam has authored several patents and technical publications and is also a frequent speaker on diamond semiconductors and clean technology as a result of his award-winning research, which he began as an electrical engineer as a student at the age of 19. Wow, that's a young age. Adam is the inventor of Mirage Diamond Platform. Adams also served as a speaker and expert witness to a variety of several bodies, including the U.S. House Space Science and Technology Committee and the U.S. Department of Energy. Adam earned his Bachelor's of Science in Electrical Engineering and Physics from the University of Illinois, Chicago, before pursuing graduate research at the Stanford University Nanofabrication Facility. Adam, that's an incredible bio, and I'd like to say thank you for joining us today. Adam, I have to say, it seems you were a bit of a prodigy at the age of 19, and to all your younger viewers, this is proof that hard work at a young age pays off. Um,
I appreciate it, Robert. Thank you so much for having me.
Thank you so much for being with us. So I have some questions for you I'd like to ask. So Adam, what excites you about the future of diamond technology, and tell us about what AKHAN is working on today.
Sure. Well, I think diamond, it has been researched for quite a while. Since just after World War II, GE commissioned the first diamond reactor using high pressure and high temperature. So for a long time, generations of researchers have understood diamond has some extreme material properties which are really beneficial for applications. But just mechanically, diamond is the hardest material we know. Has the highest thermal conductance of any 3D solids, 5 times that of copper, which, as we know, is the default heat sinking material. But more excitingly, perhaps, diamond's also a wide bandgap semiconductor. So compared to even gallium nitride or silicon carbide, diamond has much more extreme properties, which manifest in things like higher electron mobility, higher power handling, higher power density, faster RF switching, in addition to a myriad of other very favorable properties. So, I mean, overall, I'm very excited about diamond. I've been, as you pointed out, working on this field for quite some time. And now I think we're really starting to see that inflection point of progress. I mean, diamond as a quantum material has been studied and starting to be developed in very exciting ways, exploiting the optical nitrogen vacancy center there, and really opening up some interesting applications. But even diamond-based power devices for things like high power and high temperature for power inverter applications. A number of university spinouts, both domestically and internationally, are developing this, as well as traditional Department of Defense research laboratories and the private sector like AKHAN and others.
Wow, that's great. Could you give us a peek into the future from your perspective? Where would you see this technology moving to, and how is this technology going to play into our daily lives in the future?
So AKHAN's currently developing what we call three major product lines. The first, which is probably the most prevalent or most externally visible, is our Mirage Diamond Glass. Here we're taking the optical and mechanical properties of diamond and applying it for your smartphone and consumer display. And I think everybody appreciates when they drop their phone how easy it is to break or scratch these things. I mean, for the price point, we really want something more resilient. So we feel diamond is exceptionally valuable here from a break and from a standpoint. But taking it a step further, as you mentioned, because diamond is an extreme optic material and electronic material, AKHAN is also pursuing photonic device structures using our optics and our semiconductor technology, as well as traditional power devices. So we do see these being sort of tied into the future, where future displays will not only encompass a more resilient, robust hard coding screen, but also these waveguide structures and electronics, really lowering that profile and increasing the functionality of devices.
That's neat. That's neat. I was reading advanced materials like diamonds may help the U.S. recapture a leadership role in the semiconductor industry. Could you explain how and why is it important to explore new materials?
Definitely. So, as we know, the state of the semiconductor industry has been following this relationship called Moore's law, where every 2 years, the device geometry has to double and the size of the transistor has to roughly halve. And we've been approaching the singularity, as they call it, where we're actually approaching the silicon atom size. And so our ability to get both more power efficiency and increased speed is now being compromised, where we can choose either or. We can have faster devices that are running hotter, and so we have to invest more in the thermal attributes of this. Or we can have more power efficient devices, but again, they're not peak performance. And so already we've been looking at evaluating these two-dimensional materials and these stack ups to improve the heat or the thermal management. Packaging costs are exorbitant, just addressing the amount of heat that's being produced from these devices. And so a lot of work has been done in wide bandgap materials, not just diamond, but silicon carbide and gallium nitride, which really challenges the silicon's capability, at least from a power standpoint today. And so from the diamond's perspective, diamond being able to run hotter than both those two materials, being able to use less spaces, having higher power density for the same or increased performance, we see diamond as a continuation to Moore's law. But what I like about diamond, as opposed to silicon carbide and gallium nitride, is that diamond can actually be directly incorporated on silicon. So it doesn't have to be an and or. It doesn't have to be a seismic shift away from the silicon platform. Rather, diamond can be integrated at the wafer scale today to help improve some of these device structures, transitioning to a diamond age, even in logic-based devices.
Yeah. Do you have any insight into what this technology looks like in the future? How will this technology play into an advancement of small nodes and advanced architectures?
Well, I think sort of twofold. One is that, again, as you're getting the heat out of the thermal hotspots, you'll actually be able to improve the existing silicon-based architecture. But where I think that will go into maybe the medium and longer term is actually resetting the node structure, because with diamond, using larger geometries, you can actually increase higher frequencies, as I mentioned. So using micron size nodes, you can achieve several gigahertz in terms of switching speed. So I do see a sort of a setback where diamond will reset the clock from a node structure size. That doesn't mean that we'll go back to 1980s equipment. We still have to process diamond, and we still have to do the lithography on all those steps. But I see that as the continuation in the future of these device and device structures.
That's great. Adam, I would like to thank you for coming to the show and having a chat with me today. I'm sure many of my viewers have an interest in your field of diamond technology. Can you tell us more about where we can find information about AKHAN?
Definitely appreciate it, Rob. Thank you so much for having me. You can go to our website, AKHANSemi, AKHANSEMI.com for more information on us. We're also on many of the socials, Facebook, Instagram, Twitter, etc., and LinkedIn, of course.
Thank you, Move Technologies, for sponsoring this Movers and Shakers series show as we deep dive into semiconductor industry with many topics and industries with industry leaders like Adam. Check us out at www.moov.co. Thank you again for watching our Movers and Shakers LinkedIn Live series, and have a great day.